So why exactly is it that certain objects, such as wood, are able to float on water? And why is it that when you take a certain object and place that object into the fluid, that object seems to weigh less? Well, to explain these phenomena, we have to examine a principle known as buoyancy. So buoyancy is a particular concept that helps us explain why objects seem to weigh less in water and why certain objects are able to float. To examine this concept of buoyancy, let's look at the following natural phenomena. So one thing that fish are able to do is they're able to remain in place inside the water. So they're able to hover inside the water. So when a fish hovers, it essentially remains in static equilibrium. So that means the sum of all the forces acting on the object, on the fish, along any axis, let's say along the y-axis, must sum up to 0. So let's examine all the forces acting on our fish along the y-axis. So one force is the force of gravity, which is pulling our fish downward along the y-axis. And if the force of gravity was the only force acting on the fish, well then the fish would not be in static equilibrium and the fish would travel downward along the y-axis. But the fish is in fact in static equilibrium, and so that means there must exist an opposing force that has the same exact magnitude but points in the opposite direction of the gravitational force. And this force is known as the buoyancy force. Now, what exactly is the buoyancy force? In other words, where does the buoyancy force come from? Well, buoyancy force is created because fluid pressure depends on depth. Therefore, the pressure acting at the bottom of the fish is larger than the pressure acting at the top because the distance from the surface of the water to the bottom of the fish is greater than the distance from the surface of the water to the top of the fish. Once again, pressure depends on depth. So the further down we go, the more pressure we have. So that means the pressure that is created by the fluid acting on the bottom of the fish is greater than the pressure created by the fluid acting on the top of the fish. And this difference in pressure creates the buoyancy force. So let's suppose that we have the following water level, and inside the water we have the following three-dimensional cylinder that has an area, a cross-sectional area given by the capital letter L. Now the distance from the top of the fluid to the top of the cylinder is h1. The distance from the surface to the bottom of the cylinder is h2. And the difference between these two values, in other words, h1 minus h2, is given by change in h. So the pressure at the bottom of the fish creates a force. In the same way that a pressure at the bottom of the cylinder will create a force, let's call that force 2 due to pressure 2. And the pressure on top of our object, which is created by the fluid on top, creates a force, and let's call that force number 1. So we essentially want to find an equation that will give us the quantity, the magnitude of the buoyancy force. So we want to calculate the buoyancy force. So force buoyancy given by FB is equal to the change in force. So F2 minus F1, because the force on the bottom is greater than the force on the top. So F2 minus F1, well, recall that force is equal to pressure times area. So pressure at the bottom, let's call that P2 multiplied by the cross-sectional area A, minus pressure at the top, let's call that P1 multiplied by the cross-sectional area at the top. Notice these two cross-sectional faces are exactly the same. So these A's are the same. Now, recall that pressure is equal to the density of the fluid, which is assumed to be constant, the gravitational constant G, and the height. So that means this is replaced with the density multiplied by G multiplied by A multiplied by the height h2, where the height h2 simply the height from the surface to the bottom of our container where the force is acting. And we replace P1 with the density times G times A times H1, where H1 is the distance from the surface to the top of our cylinder. Now notice our density G and A are all the same quantities and they appear on both sides. So we can take that quantity out and we get the following result. And since H2 minus H1 is simply the change in H, we can replace that to get the following result. Now notice what A times change in H is. Change in H is simply the height of our shape of our cylinder, and if we take the cross-sectional area A and multiply it by the height, well, we simply get the volume of our object, the volume of our cylinder. Now notice this density is the density of the liquid, and this volume is the volume of the object. So this entire product, the product of the density of the liquid and the volume that the object takes up, is simply the mass of the liquid displaced by the object. And we can replace this quantity with mass, because mass is equal to density times volume. So we see that the buoyancy force acting on our object that opposes the force of gravity is equal to the mass of the liquid multiplied by G, where this entire quantity is simply the weight of liquid which takes up the volume equal to the volume of the object. Once again, what exactly is the force of buoyancy? Well, the force of buoyancy is essentially the force created by a difference in pressure between the top and bottom of our object, and it's equal to the weight of the fluid that is taken up by this volume. And it points in the opposite direction of the force of gravity.